Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so let's move on quickly. In the previous video, due to some technical problem, the video was incomplete. Okay, we are discussing covalent bond, and in the last part, we are discussing the formation of chlorine, isn't it? You have seen that the chlorine formation. Okay, so topic that we are discussing is covalent bond, and we have been showing the formation of chlorine molecule. So chlorine, as you see, okay, so chlorine covalent bond is of three types: single, double and triple. For single covalent bond, consider chlorine atom. I am just showing that formation once again. Single covalent bond, what happens? See, the chlorine atom has 7 electrons in the outermost shell. 1, 2, 3, 4, so 5, 6 and 7. 2, 3, 4, 5, 6 and 7. Okay. Now this pair of atoms are being shared by the two chlorine pair of electrons are being shared by the chlorine atom between themselves. Okay, and it leads to a formation of structure like this. The chlorine atoms overlap at a certain point. Okay, and these shared pair of electrons lie in the overlap region. Other electrons are present in the shell as it was 3, 4, 5, 6, 7, 8. 3, 4, 5, 6 and then 7, 8. Okay, so this is the region where the shared pair of electrons are present, and this is a single covalent bond. This is an example of single covalent bond. Okay, fine. Now quickly moving on, double covalent bond. If you consider double covalent bond, you can consider oxygen atom. So oxygen atom has 6 electrons in the outermost shell. Okay, so let us just mark out those 6 electrons: 1, 2, 3, 4 and 5 and 6. 1, 2, 3, 4, 5 and 6. Okay, so here it has to share 2 pair of electrons. Why? Because one oxygen atom has only 6 electrons, so it needs further 2 electrons to attain the electronic configuration of nearest noble gas. So how will it get 2 electrons? If it shares 2 pairs of electrons. Thus the oxygen molecule form will be showing some structure like this. Okay, some structure like this. So here is one, here is another, here is one, here is another. Okay, fine. Now see. So 1, 2, 3, 4, 5, 6 and 7, 8. 1, 2, 3, 4, 5, 6 and 7, 8. Okay, fine. So here in this region 2 pair of electrons are being shared, that is 4 electrons are being shared. So you can say that this type of bond is double covalent bond. Previous was only 1 pair of electron was shared. It is a single covalent bond. Okay, take another example of triple covalent bond. Can you just lower the camera a bit, then it will be coming in one single page. Okay, so let us just show the formation of double covalent bond. Okay, triple covalent bond. Fine. Okay, so in case of triple covalent bond, okay, so consider nitrogen atom. Okay, so nitrogen atom, as you know from the configuration, it has 5 electrons in the outermost shell. So let us just point it out. 5 electrons in the outermost shell. Okay, so 1, 2 and 3, 4 and 5. 1 and 2, 3, 4 and 5. So here is one electron pair that is being shared. Here is one electron pair that is being shared, and here is one electron pair that is being shared. Okay, so 3 electrons pairs need to be shared. Why? Because as we have said that in order to have stable electronic configuration, Nitrogen atom tries to attain the electronic configuration of neon element, and neon has 8 electrons in the outermost shell, so definitely nitrogen will also have 8 electrons in the outermost shell, like this. So if we see the configuration of the nitrogen atom, nitrogen molecule, it is something like this. So it will be like this, okay. Another nitrogen atom, it will be having something like this, structure like this, okay. And in between space we have 3 pair of electrons, because 3 shared pair of electrons, 3 electron pairs are being shared, okay, fine. Now see, so already 6 electrons are present, 7 and 8, 6 electrons are present, 7 and 8. So if I consider these structures, you see that in this common phase, if it is triple covalent bond, then 3 electron pairs are being shared. 3 electron pairs are being shared. Is it visible? Yeah, it's visible. Okay. So this is the structure of a triple covalent bond. Now see, the electrons are not being totally given away. They are not being totally given away. They are being shared. And if we just take this counting here, this nitrogen atom has 1, 2, 3, 4, 5, and then 6, 7, 8 electrons. From the, if we see from the side of that nitrogen atom present in the right side, then also this has 1, 2, then 3, 4, 5, 6, 7, 8 electrons. Likewise, you can see in oxygen molecule also, the oxygen atoms, both the oxygen atoms have 4 electrons of their own, and they are sharing 4 electrons further. So if we just add up the number of electrons that are being shared and that are being present on their own shell, the sum turns out to be 8. So this is how covalent bond is being formed, and single, double and triple covalent bonds are correspondingly formed. Okay, so the concept I think is clear. Fine. So this is how bonding is done, okay, and electrons are being shared to form bonds, covalent bonds, okay. So I think the concept, both the concept electrovalent bond or ionic bond and covalent bond are clear to both of you, to all of you, okay, both these bondings, okay. So we will be discussing some more structures like this for electrovalent bond also, for covalent bond also, and then we will be moving on to the coordinate bond. So in the next class I will be discussing further some of the more bonding structures. We will be taking up some compounds like ammonia, methane molecule, okay, then calcium oxide. These compounds will be taken up and they will be discussed, and their structures will be discussed, okay. So with this we come to the end of this brief class. I hope the concept is clear. If you have any query, please do mention it in the comment box. We'll be happy to solve your problem. Thank you. Goodbye.